Okay, good morning. So I quite enjoy this topic. We're going through data representation of images and sound, one that we haven't done that much of in the past. It always tends to come up in a paper one exam. It's quite nice and easy and quite nice and creative once you get your head around what's going to come up. So you've heard these terms. Now we want to define them properly. So bitmaps, pixel, resolution, and color depth. Resolution is an awkward one because it's misused a lot, and there's a very particular interpretation of that word for Edexcel GCSE Computer Science. We've come across this phrase before, construct an expression. That means we don't actually calculate. We write down what we would what we would put into a calculator, bearing in mind you're not allowed a calculator in the exam. We need to tell the difference between image size and image resolution. Coming back to that word to make sure we've understood it properly. So you know binary means two states, zeros and ones. If we use that, then we can combine them in any possible way to get not just 0 and 1, we can get hexadecimal, or we can get denary, or we can get color, or we can get sound, or we can get animation, we can get video. If we're clever in the way that we use these zeros and ones, we can represent all information. You know all of that before. So a bit is just a single 0 or 1. We've got too many colors here to represent these using single zeros and ones, so we're going to have to use more than one bit per pixel. A pixel is just one picture element, a picture cell. So we're going to need two bits per pixel, because we've got, well, how many have we got? 1, 2, 3, 4. 4 colors means 2 bits. So we've seen this before. 2 to the power n is the maximum number of different representations. In the past, we've just seen that with numbers. It's the same with colors. We've got 256 different colors. We're going to need 8 bits because it's 2 to the power 8 to represent that. So we've seen all of that before. As well as the actual data, like 0, 0, 0, 1, 1, 0, we're going to need some metadata here so that the computer knows how to interpret that data, as in how wide and how long, how tall it is. And then the color depth, as in how many bits per pixel. I've deliberately not defined this. So what do we think the resolution actually means? It is the number of pixels per inch. As in, if you were to measure an inch going across and count how many pixels going across there would be. It is not the measure of pixels per square inch. It's the number of pixels going across in a linear inch. So let's have a look. If we were to represent this image, we've got a particular pattern for one color, blue, 0 and 1. Particular pattern for white, 0, 0. You get the idea. It's quite nice and simple. So let's just go straight on to the P13 activities. Here we go. You need to define these. You've got your definitions on here. And then we have a lookup table of 0, 0, 0 being black. And you just fill it in. Sorry, it's moved onto the wrong screen. So I would recommend just right-clicking and filling in a particular color. There we go. And you can do all of the ones at the same time if they line up. So this is going to be tricky. How many have we got? The width is, oh, it's in binary. So 1, 2, 4, 8. It should be 8 by 8. So the first thing I would do is 1, 2, 3, 4, 5, 6, 7, 8. I'm going to lay these out as they are below to make it a lot easier to see the representation of the image. So once you lay up the binary data in a grid according to the metadata, it's going to be a lot easier to work out what all of the colors are. And then you can investigate and try and see what the actual picture is. So I think you can kind of see what that's going to look like now. Looks like a flag to me. See if you can work it out. So we didn't get time at the start of the lesson to go through how to calculate the size of an image, but it's fairly logical. If you want to work out the total number of pixels, you do the width in pixels multiplied by the height in pixels, and that gives you the total number of pixels. That is not the resolution, that is the total number of pixels. If you wanted to find the resolution, you would take the width and divide by the width in inches, or the height and divide by the height in inches. But we're not trying to do that here. We're trying to calculate the size in mebibytes or kibibytes or etc. etc. So to do that, We'd work out the total image size. We wouldn't calculate it. We'd construct an expression, which means writing down what we would put into the calculator. And then we'd have to work out how many bits per pixel. For example, if there are 8 bits per pixel, we'd have to multiply this by 8. If there's 16 bits per pixel, then we'd have to times this by 16. Often there are 24 bits per pixel, 8 bits for the amount of red, 8 bits for the amount of green, and 8 bits for the amount of blue. This afternoon we'll do some examples of that. So 3 bytes, 24 bits per pixel. So you do all of that multiplied by 24, and then you'd have to divide by 8 to go from bits to bytes. And then you might have to divide by 1024 to go to kibibytes, or maybe have to divide by 1024 again to go into megabytes, depending on the question. So just to confirm, image size is the height by width. The resolution is going to be how many pixels per inch. So I think you've got enough now to be able to work through all of activity 3. The file contents down at the bottom here means you would have to represent all of the file in here. So really, the file contents would include the metadata and the color table, but what the question is just asking you for is the file contents here. So for example, white, you'd have to choose a bit pattern for white, and then we'd have 2 bits for white, 2 bits again for white, 2 bits again for white, and then we need a bit pattern for yellow, and you get the idea. So we've had a really good question here. How can we work out the resolution if we don't know the width? I'm just going to tell you that the width of this image is 1 inch. And if we've got 1, 2, 3, 4, 5 pixels, it's going to be 5 divided by 1, which is 5 pixels per inch. That's it. So this needs saving and submitting, please, to half term 9 data 3, please. Save your Word document first, submit it to half term 9 data 3.